In this session, I will discuss about generation and detection of AM wave. First of all, we will discuss about amplitude modulator. So, amplitude modulators are used to generate amplitude modulated wave or AM wave. That means the circuit that generates the AM waves is called amplitude modulator or AM modulator. Basically, there are two different types of modulators or AM modulators are used, that are square law modulator and switching modulator. First of all, let us see what is a square law modulator. Square law modulator contains a nonlinear device, that may be a diode or a transistor, a band pass filter, a carrier source and a modulating signal. These are the main constituent of a square law modulator. And figure shows the square law modulator block diagram, and in this figure you can see there is a nonlinear device, that may be a diode or a transistor, and there is a modulating signal x of t, that is the information signal or a message signal, and a carrier signal, and its value is e z cos 2 pi fc into t. This is actually omega c t. Omega c is 2 pi fc. And the carrier signal frequency is higher than that of the modulated signal frequency. And these two signals are given to the nonlinear device. And let V1 of t is the voltage at the input of this nonlinear device, and V2 of t is the voltage at the output of the nonlinear device. Then the output of the nonlinear device will be given to a band pass filter. Here it is given that it is a tuned circuit tuned to Fc, and it acts as a band pass filter. And the output is taken across this resistance, which is denoted as RL. Actually, it is a load resistance. So, V out is the output. So, here the function of the nonlinear device is, which is used to, that nonlinear device is used to modulate the carrier signal in accordance with the modulating signal. So, this is a nonlinear device, and basically it will be a diode or a transistor, and it is used to modulate the carrier signal, and that is the carrier amplitude will be varied in accordance with the amplitude of the modulating signal. So, here nonlinear device act as a modulator, and the combination of the modulated signal and a carrier signal in nonlinear device produces an AM signal. And also there will be other frequency components at the output of this nonlinear device. See, nonlinear device act as a modulator, and this combination of this modulated signal and carrier signal is given to this nonlinear device, and it produces the amplitude modulated wave at the output of nonlinear device. But along with this amplitude modulated wave, there will be some other frequency components present, and those components are DC level. Some DC level will be added to at the output of the nonlinear device, and there will be original carrier frequencies and original message or modulating signal frequency. That means the carrier frequency is Fc and modulated signal frequency is Fm, and both these frequencies will be present at the output of this nonlinear device. And also there will be upper sideband frequency, that is Fc plus Fm frequency, and lower sideband frequency, that is Fc minus Fm frequencies, and also harmonics of USB and LSB frequency. That means harmonics means twice the frequency of USB and twice the frequency of LSB, or thrice the USB frequency or thrice the LSB frequency, such that is why we are called harmonics, means repetitions, periodic repetitions of the same frequency is called harmonics. And so at the output we will have along with the AM signal we will have different unwanted frequency components and also some DC level. So at the output of the nonlinear device we have to filter all these unwanted components. That is why we are using a band pass filter at the output. See, you can see here that there is a tank circuit which acts as a band pass filter. That means the required frequencies will be passed to the output and others will be cancelled. That means band pass filter means it allows the flow of a particular band of frequencies. Other frequencies will be rejected. That means they will not go to the output. So the bandpass filter removes the DC level and the harmonics of USB and LSB frequencies, and after filtering the AM signal, that means the carrier frequency and the USB and LSB will be there. So we will get the amplitude modulator signal at the output. So this is the square law modulator, and that it is its function. That means here the important thing is that nonlinear device acts as a modulator and it produces the AM wave at the output, and there will be other frequency components along with this AM wave, and that frequencies components will be filtered out by this bandpass filter, so that the AM wave with the upper sideband, lower sideband, when with the carrier frequency will be appear across the load resistor RL. So next we will discuss about the switching modulator, which is another type of AM modulator, and this is the diagram of the switching modulator. Here you can see that there is a diode which is a nonlinear device, and a modulated signal and the carrier signal is applied in series to this diode, and the output is taken across the resistor RL. Let us see how this diode produces amplitude modulated wave. Usually here here diode is acting as a modulator, and also we know that diode is like a switch. That means diode has got a property, that is it is a unidirectional conductor. That means when the positive voltage come at the P side of this diode, it will be forward biased. When negative voltage come to the P side of this diode, then diode will be reverse biased. That is its function. So we can say that it acts as a switch, and here in this case here it acts as a modulator. So modulating signal, that means here it is denoted as X of t, and carrier signal is denoted as C of t, and C of t is EC cos 2 pi FC into t, or EC cos omega C into t, that is a carrier signal. So here modulating signal X of t and carrier signal C of t are connected in series, and they are given to the input of the diode. So the input voltage of the diode will have the equation, that is the sum of both these voltages, that is V1 of t will be equal to C of t plus X of t. See here V1 of t is the input voltage, and here at the input both the modulated signal voltage and the carrier signal voltage appears. So V1 of t will be equal to X of t plus C of t. So we can write, instead of carrier signal, EC cos 2 pi FC into t plus X of t. So this is the input voltage at the nonlinear device. Also here you can see that we are taking the carrier signal amplitude which is greater than that of the modulated signal voltage. So you know that the frequency of the carrier is higher comparing to the frequency of the modulated signal. So when a positive half cycle of the carrier appears, the diode D will be forward biased. See, this is the carrier signal and this is the modulated signal, and the carrier signal frequency will be higher comparing to the modulated signal frequency. And also we are taking that the carrier signal amplitude is higher comparing to the modulated signal amplitude. When both these waves comes to this diode, since when in the positive half cycle of the carrier signal, the diode will be forward biased, because positive will come to the P side of this diode, so it will be forward biased. As a result, we will get the modulated signal at the output. So similarly, when the negative half cycle of the carrier signal comes, that means the voltage applied at the P side of the diode will be negative, so that it will be reverse biased. At that time there will not be any output at the N side of this diode. So in the negative half cycle of the carrier, the diode D is reverse biased and it acts as an open switch. Open switch means it offers infinite impedance, so that no voltage appear at the output of this diode. So we can write the output as a V2 of t. Here see, you can see V2 of t is the output. At the output, V2 of t will be equal to, what is the value of V2 of t? V2 of t will be equal to X of t plus C of t during the positive half cycle of C of t, and V2 of t will be equal to 0 during the negative half cycle of C of t. So V2 of t can be written as that will be equal to V1 of t. What is V1 of t? V1 of t is the sum of modulated signal and carrier signal. That will be equal to C of t plus X of t. That means here the input signal is modified by adding the carrier signal to it. So this signal will be obtained at the output of the nonlinear device when C of t is greater than 0. That means during the positive half cycle of the carrier signal. When the negative half cycle of the carrier signal appears, that means C of t is less than 0. At that time, diode will be reverse biased. So it acts as an open switch. So no voltage appears at the output. That is why we are putting a 0 here. So this is the output voltage equation in the case of a switching modulator. So next we will go to, up to this we have discussed about the generation of AM wave. That means we discussed about how the AM waves are produced from the modulated signal and carrier signal. Next we will go to the detection or demodulation of AM wave. Actually detection or demodulation is the opposite or reverse process of modulation. That means demodulation or detection is the process by which the modulating voltage is recovered from the modulated signal. That means we will have an amplitude modulated wave, and in the demodulation process that amplitude modulated wave will be demodulated or detected to information signal. That means demodulation or detection is the process by which the modulating voltage means information or message signal or baseband signal voltage that is recovered from the modulated signal. So we can picturize that demodulation process. Here we will have an amplitude modulated wave. See, this is the amplitude modulated wave, and we will apply this to a demodulator or detector circuit. As a result, this detector circuit converts this AM modulated wave to information signal. Information signal is the envelope of this signal. So we will get this as the information signal, which is the original message signal or baseband signal. So there are different types of detection methods for AM signal. Square law detector or demodulator will be there. Envelope detector or envelope demodulator will be there. Synchronous detector or synchronous demodulator will be there. Here we will discuss about the envelope detector. So let us see the envelope detector. From the name itself we can say that here the envelope will be detected. So let us see how it happens. Here this is a circuit diagram for the envelope detector. Here there is an AM wave at the input, and this is the envelope detector circuit, and the output will be the modulated signal or baseband signal or information signal. Here you can see that high frequency carriers are not there. That means high frequency carriers are removed by this circuit. So what are the components in this circuit? There is a diode, capacitor and a resistor. See, this diode acts as a nonlinear device, and this capacitor and resistor act as a filter, which is a RC filter, and which is used to filter out the high frequency components, so that we will get the unmodulated signal. That means information signal at the output. So the diode envelope detector produces an output voltage that will be proportional to the envelope of this signal. That means which is the information signal. So the output of this circuit will be the envelope of the original message signal, or envelope of the AM signal, which is the original message signal. So this is a diagram which shows the detection process by using waveforms, and also this is a circuit diagram. Let us explain this by using this circuit diagram. See, actually initially the AM wave was like this. See, this is the envelope of this AM wave, and a high frequency carrier is shown like this. That means this is the amplitude modulated wave, right? In the amplitude modulated wave, you can see the frequency will be increased, right? Frequency. Why we are modulating a wave? In order to increase the frequency of the signal, we are modulating the signal. The amplitude modulated, amplitude of the carrier will be varied. So by the process of modulation, we will increase the frequency of the signal, and here the frequency will be the carrier frequency, right? So let us see. Here some parameters are marked. Let us see by explaining this circuit diagram. See, once we are giving this amplitude modulated wave at its output of the circuit, see, at the input of the circuit, see, there is a diode. You know that what is the property of the diode? Diode acts as a switch, right? That means when a positive voltage appears at the P side of this diode, this is the P side. When a positive voltage appears at the P side of the diode, diode will be forward biased. So when positive half cycle comes, this is a positive value up to this point. The diode will be forward biased. So that means whatever be the voltage that will be passes through this diode. That means that positive cycle passes through this diode, and when it reaches this point, you can see that there is a capacitor and a resistor, and the capacitor offers a low impedance to the higher frequencies, so that positive cycle will passes through this capacitor. That means capacitor starts charging. How much up to what level this capacitor charges? That means the capacitor will charge at the peak voltage value of the RF signal. See, this is a positive cycle, and during that diode will be forward biased, and that positive cycle will travel through this diode. Once it see the capacitor, it will go through this path, because capacitor offers low impedance to higher frequencies. That is why the positive half cycle passes through this. So that due to that passing, the capacitor will be charging, and capacitor will charge to the peak value of this RF signal. RF signal means this carrier signal, right? Because it has got a higher frequency. That is why we are saying that it is a RF signal. RF signal means a radio frequency signal. Since it has got a higher frequency, so it is a radio frequency signal. So this capacitor will charge to the maximum voltage of that RF signal. So the capacitor will have the maximum voltage appears across it. But when this voltage reaches the 0 point, then the cycle will be reversed. See, the negative cycle will appear. When the negative cycle appear at the input of this diode, then the diode will be reverse biased. That means the diode will become open. When negative cycle appears at the P side of the diode, then diode will be open. That means there is no passing of carrier wave or the signal through this diode. But what is the property of the capacitor? Capacitor will hold the charge. That is, now the capacitor voltage was this peak value. When negative cycle comes through this diode, this path will be open, but the capacitor holds the charge, but up to a certain point, but it starts discharging that charge through this resistor. But it will not completely discharges through this resistor. When it starts discharging through this resistor, then again positive cycle comes. So here you can see there is a point. This is the discharging path of capacitor. See, there is a slanting line here, darkened slanting line here, that represents the discharging path of capacitor. When it reaches up to this point, then the negative cycle, then the second positive cycle comes. When second positive cycle comes, the diode again become closed. That means that cycle passes through this one. That means the capacitor again starts charging. That is why next peak of this charging cycle comes. And when the next positive cycle passes through the capacitor, it again starts charging to the peak value of the RF signal. When it reaches its peak value, see, then the next negative half cycle comes. When next negative half cycle comes, the diode again reverse biased. That means this part will become open. So the capacitor starts discharging through this resistor, and this point is represented by this slanting line, darkened slanting line. This is the discharging path of capacitor. But the capacitor will not completely discharge, because before that again third positive cycle comes, so that diode will be again forward biased. So this process continues. As a result, at the output is taken across this load resistor. So at the output we will get this portion. That means the charging and discharging of this capacitor wave obtains. And when we are analyzing this, we will get approximately the shape of the envelope circle. That means these higher frequencies will not be obtained at the output because due to this effect, because higher frequencies will be passed through this capacitor, because it acts as a filter circuit, and we will get the envelope of this capacitor charging and discharging at the output. And see, here there is some ripples present at the output, that is due to the charging and discharging of the capacitor, and that can be smoothened, or that ripples can be avoided by using suitable values of R, because it will completely avoids those ripples due to its filtering action. So finally we will get an output, smoothened output of modulated signal at this output. See, you can see this is a smoothened signal, and which is similar to the envelope of this AM signal, so that when we are giving this signal to this input, we will get an output of this signal. That means original modulated signal is obtained at the output. So this is working. That means circuit contains diode and filter, and diode act as a rectifier. When the input voltage is positive, diode becomes on and the current flows through it. So capacitor starts charging to the peak value of RF signal or carrier signal. During the negative half cycle of the input RF signal, that means input to carrier signal, diode becomes off. RF signal means radio frequency signal. Here we are using RF term because the carrier frequency is higher frequency. That is why we are using the term RF. But the capacitor holds the positive charge previously received. So the output voltage remains the peak positive value of RF. There will be some discharge of the capacitor which produces ripples in the output waveform, and these ripples can be filtered out by RC filter. The capacitor C provides low impedance to the carrier frequency and provides high impedance to the modulating frequency. So higher frequencies will be bypassed and high frequency carrier is removed. That is the working of this envelope detector. So that's all about the detection of the AM wave. Thank you.